Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
Last week, we kicked off a mini-series on data frames by learning about the relationship between a matrix, a table, and a data frame. I'm assuming that you've already watched that tutorial. If not, please watch that tutorial before watching this one. The link is in the description below. Today, we'll be using data frames to analyze the world population by region, by subregion, and by country for 2018 and 2019. By the end of this tutorial, you'll know how to get data off the internet and into a data frame. You'll also know the basics of data wrangling, which is the art of preparing your data for analysis. Finally, you'll be able to perform some basic descriptive analysis on some real-world data. The real world is waiting for us, so let's get started right away by setting up our programming environment. Open VS Code and maximize the terminal panel. Start the REPL by holding down the Alt key and then hitting J and O. Make a new directory called tutorial02x07 by using the make directory function. Change your present working directory to your new directory by using the change directory function. Enter the package REPL by hitting the close bracket. Activate your new directory by typing in activate space period and then hit enter. Add the following packages and versions. Type in status to confirm that all of the correct packages and versions have been added. Exit the package REPL by hitting backspace. Minimize the REPL. Create a new file by going to File, New File. Save the file as tutorial02x07.jl by going to File, Save As. Be sure to save your file in your new directory. I'm going to add a header to my file, but there's no need for you to type this in. You can access the source code for this tutorial in my GitHub repository. The link is in the description below. For the past several tutorials, I've been telling folks to go to my GitHub repository, but it's occurred to me that I've never explained how to access my code there. So here's a quick GitHub tutorial. First of all, you do not need a GitHub account to access my code. Just go to github.com and search for Julia4TA/tutorials. Click on the link. Click on the Series 02 folder. You should see all of the folders for this tutorial series. Let's click on last week's tutorial folder. Click on the tutorial02x06.jl file. Click on the button labeled Raw. Clicking on the Raw button generates a plain text version of my file. Press Ctrl A to select all of the text. Press Ctrl C to copy all of the text. Now, go to VS Code and open up a new blank file. Press Ctrl V to paste the code. To save it, simply go to File, Save As, and save it as a .jl file. And just like that, my code has become your code. And not just my code, but all of the code on GitHub is yours for the taking. Welcome to the world of open source. You can close this file without saving it since we will not be using it today. However, there is a different file that we will be using. Go back to your browser and click on the back arrow to get back to GitHub. Select the Series 02 link to get back to the list of folders. Click on the Files folder. Click on the Save HTML.jl file to open it. Just like before, click on the button labeled Raw. Press Ctrl-A to select all of the text. Press Ctrl-C to copy the text. Go back to VS Code and click in the tutorial02x07.jl file. Press Ctrl-V to paste the code. Go ahead and select all of the rows and then hit Shift-Enter. Okay, that concludes the mini GitHub tutorial. Enjoy exploring GitHub. Now, let's get back to data frames. If you're a professional analyst, you have access to your company's data. However, if you're a hobbyist like me, then you probably don't have a lot of data lying around at home. For the rest of us, we get our data off the internet. There are many sources of free data online. Today, I'm going to show you how you can grab a table off of Wikipedia. In your browser, do a search for population by country. Select the Wikipedia article titled List of Countries by Population, United Nations. This article contains a table that we will use in our analysis. Open up a new tab in your browser and do a search for Wikipedia Table to CSV. Select Wiki Table to CSV Online Converter. This online converter was created by Gregor Weichbrot and generously made available for free under the MIT license. I apologize for my pronunciation. There's a way of doing this using Julia code, but it's outside the scope of this tutorial series. For now, let's take advantage of this online converter. Go back to the Wikipedia article and copy the URL. Go to the Converter tab and paste the URL in the page URL box and click on the Convert button. This converter identifies anything that looks like a table and presents you with the option to either download it or to copy it to your clipboard. Select Table 2 and copy it to your clipboard. In VS Code, open a new file by going to File, New File, and hit Ctrl-V to paste the data into the blank file. Save the file as population.csv. Go to View, Command Palette, and select Convert to Table from CSV. Save this file as populationtable.txt. And just like that, you've grabbed a table from Wikipedia and transferred it to your computer. Close the tabs, leaving only the .jl file. Next, we're going to use the skills that we learned in last week's tutorial to convert the CSV file into a data frame, and then to save that data frame as an HTML file that we can view in VS Code. You can add multiple packages on the same line by separating them with a comma. Next, construct a data frame by using the dataframe constructor along with the csv.file function. Maximize your REPL and type in df to view your data frame. As you can see, it omits a lot of data. Minimize the REPL and go back to the editor. In order to get a better look, let's save the data frame as an HTML file. Open the Explorer and click on your HTML file to view it in VS Code. Close the Explorer panel to expand your view. This is a table showing the world population by country, sorted from high to low, for the years 2018 and 2019. The last row contains the world totals of 7.6 to 7.7 billion people. In order to perform analysis using this data, we will first need to clean it up using a process known as data wrangling. Maximize your REPL and type in df to view your data frame again. As you can see, the Julia data frame displays row numbers. However, the row numbers are not visible in our HTML file. Let's add a column containing an index number that will serve as our row number. This code comes directly from one of Bogomil Kaminski's tutorials. You'll recall from last week's tutorial that df.id will automatically create a new column in the data frame. The selectBang function creates a new data frame containing the columns that you specify from the data frame that you specify. This code creates a new data frame with the ID column as the first column, followed by the rest of the columns. Let's save this data frame as an HTML file and then take a look at it. Open the Explorer and click on this latest HTML file. Close the Explorer tab. Notice that it's the exact same data, except now it has an ID column with the numbers 1 to 234. Adding an index column is a good start, but what's the deal with the header names? Let's change the header names into something shorter. You can rename all of the header names at once by using a vector containing the header names listed as symbols. To replace the existing header names with your new header names, simply include the headers vector as an argument in the renameBang function. I'm going to copy and paste the save HTML line from above using Ctrl-C and Ctrl-V. Click on the Population Working HTML tab. Your HTML file should automatically update every time you save. Okay, so we added an index column and renamed the headers. Now, what's going on with the population figures? It looks like they were loaded in as strings and not integers. We need to convert these population strings into integers. But before we can do that, we need to get rid of the commas. The replace function is from base Julia, and it works the same way in a data frame. Click on the Population Working HTML tab and notice there are two new columns containing the population figures without the commas. However, the data in those columns are still strings, so now we need to convert the strings into integers. The parse function is from base Julia, and it works the same way in a data frame. Click on the Population Working HTML tab and notice that there are two new columns containing the population data listed as int64. This is what we need. But these numbers are so large, it's difficult to comprehend. Let's change this data from people to millions of people. The round function is from base Julia, and it works the same way in a data frame. Click on the Population Working HTML tab to view the latest version of your data frame. Okay, how are we doing? The original table contains a column showing the year-over-year percent change, but it doesn't contain a column showing the year-over-year change in the actual number of people. Let's add a column showing that data. Click on the Population Working HTML tab. As expected, it created a new column containing the calculated values. A positive number indicates population growth, and a negative number indicates a declining population. Now, let's create another column calculating the year-over-year percent change. If all goes well, it should be identical to the wiki percent column. By doing a quick scan of a few numbers, it appears that our calculated values are the same as the data in the original table. Let's check the last row to make sure that the totals are the same. View this latest HTML file in your browser. This data frame is starting to become more useful, but now it has too many columns. Let's see how we can set up a new data frame that contains just the columns that we want, positioned in the order that we want. Start by setting up a vector containing the columns that you want in the order that you want. Then, use the select function to create a new data frame. Save your new data frame as an HTML file. Open the Explorer panel and click on your new HTML file. You should now see a table with 234 rows showing the region, subregion, and country name for every country in the world. Next, you should see the 2018 population estimates in millions of people, followed by the 2019 population estimates in millions of people, followed by the year-over-year change in millions of people, and then followed by a year-over-year percent change. Before we can celebrate the completion of our data wrangling exercise, we have one last issue to deal with, and that's the issue of what to do with the last row containing the totals. The totals row is not actually part of the dataset. Those are calculated figures, and their placement in the table is not consistent with the tidy data format. However, you should not simply delete the row. I'll show you why in a few minutes. For now, let's preserve this data in a new data frame so we can refer to it later. This is the data we want. However, this creates a new data type called a data frame row. This is not what we want. We want an actual data frame, which we can make by using the data frame constructor. Go ahead and save this data frame as an HTML file. Open the Explorer panel and click on the new HTML file. Finally, let's delete that last row from MyDF. Click on the mydf.html file and confirm that the last row has been deleted. Now that we have a clean dataset to work with, the next step is to go through a descriptive analysis to better understand our dataset. A good place to start is with the describe function. Open the Explorer and click on your new HTML file. Looking at the 2019 population row, we can see that the average population by country is around 33 million people. However, the median is only 5.5 million people, in a range from roughly 1,000 people to 1.4 billion people. Clearly, there are a few large countries that are throwing off the average. You may be wondering why the describe function in data frames doesn't calculate the standard deviation or the quartiles. Well, it does. It just doesn't show it to you by default. The describe function in data frames does several calculations behind the scenes, and you can choose to display them if you like. Again, looking at the 2019 population row, we can see that the standard deviation is roughly 135 million people with a mean of 33 million people, which is a very large deviation. You can also see that the first quartile is under 500,000 people, while the third quartile jumps up to 20 million people. Between the third quartile and the maximum is a difference of over 1 billion people. Let's take a look at the different regions. In order to get a list of all the unique regions, use the unique function. This is a 5-element array, so we can take a look at it using VS Code Display. Click on the values header to sort the list alphabetically. Let's take a look at the subregions. At 22 elements, it's a longer list. Still, 22 subregions for 233 countries seems like a reasonable split. Let's take a look at the list using VS Code Display. Click on the values header to sort the list alphabetically. Close all of the viewing tabs, leaving just the .jl file open. Now, let's take a look at the list of countries by sorting our data frame alphabetically by country. Open the Explorer and click on mydf.html to view your data frame. It should now be sorted alphabetically by country. The sort function is from base Julia, and it works the same way with data frames. Using the sort bang function makes it a permanent sort. While sorting alphabetically by country makes it easier to find your own country, it might be more meaningful for analytic purposes to sort by region, then by subregion, and then by country. Let's see how we can sort a data frame using multiple columns to determine the sorting order. Use a vector to pick which columns to use to determine the sorting order. This is a more manageable list to go through. I didn't realize that Mexico was included in the Central America subregion, or that Greenland was included in the Northern America subregion. Let's add up the populations by country to get the totals for 2018 and 2019. Now, let's take a look at the values from the last row that we deleted from the original data. Does anything look off to you? The overall percent change looks okay, but everything else looks off. Let's take a look at how far off we are. The total population count is off by almost 3 million people for both 2018 and 2019. While this doesn't have much of an impact on the year-over-year percent change, that's like missing the entire population of a large city like Chicago. I'm not sure why the Wikipedia data by country doesn't add up to the total. I did track down the original source document from the United Nations. The Wikipedia figures by country are different for several countries. The Wikipedia article does not contain footnotes explaining why their figures are different than the figures from the United Nations. If you're interested in seeing the source document from the United Nations, a link is in the description below. So this is a very important lesson. always be cautious with any information you get from the internet. Except, of course, for the information that you receive from my YouTube channel, since my information is always 100% reliable. Obviously, I'm kidding. Like everyone else, I too make mistakes. When watching my videos, you should apply critical thinking to form your own opinions concerning the information being presented. Critical thinking should be applied to any information that you receive, whether it's from the internet, from a textbook, or from any other source. In any event, for the purposes of this tutorial, I will disregard the totals from the original Wikipedia article and go with our calculated totals, since these are all just estimated population figures anyways. Before we move on to the next section, let's add one more column to our data frame. Let's add a column showing the percent contribution of each country to the total world population in 2019. The sum of this new column should add up to 100%. Confirm that this new column adds up to 100%. Okay, so it's off slightly because of the rounding, but that's close enough for our purposes. Looking at all of the individual countries can be overwhelming. It would be helpful if we could group this data by region or by subregion. Let's take a look at how we can do that in data frames. To group data in data frames, use the Group By function. For grouped data frames, the convention is to use GDF to distinguish it from a standard data frame. However, since I'm already using MyDF, let's use MyGDF for our group data. Using the Group By function creates a grouped data frame, which is a different data type that is difficult to display. You can get a sense for what this group data frame looks like in the REPL by including the allGroups keyword argument when using the show function. Maximize the REPL to see the group data frame. A group data frame can be difficult to work with. However, we can combine a group data frame into a more useful summary data frame by using the combine function. When using the combine function, pair the column name with a function. In this case, we've paired our column names with the sum function in order to get the subtotals by region. The output is a 5x4 data frame that we can easily see just by hovering over the output. Let's add a couple of columns with the percent calculations to keep our combined group data frame consistent with our main data frame. Open the Explorer and click on mygdf_c.html to view your latest combined group data frame. Now that's a compact data frame with a lot of information. Before moving on, let's check the totals. Looks good. The totals for our group data frame matches our main data frame. Let's perform some different sorts to our combined group data frame to see what we can learn from it. Open the Explorer and click on your new file to view it. So, the fastest growing regions by population in 2019 were Asia and Africa, with a combined population growth of roughly 73 million people. Open the Explorer and click on your new file to view it. This sort is not as useful. The Oceania region was the second fastest growing region by percentage in 2019, at a growth rate of 1.33%. But that was on a starting base of only 41.6 million people, so they only grew by 554,000 people. Open the Explorer and click on your new file to view it. Roughly 80% of the world live in either Asia or Africa. The size of the Americas is surprisingly small, considering that the Americas region covers North, Central, and South America. Now that we have a feel for how to group and combine data, let's go through the same exercise using the subregions. This may seem repetitive, but repetition is the key to learning how to use the data frames package. To group the data by subregion, simply replace region with subregion when using the group by function. As a reminder, you can get a sense for what this group data frame looks like in the REPL by including the all groups keyword argument when using the show function. Maximize the REPL to see the group data frame for subregions. When combining this group data for subregions, we can include a column showing the associated region by pairing it with the unique function. The output is a 22 by 5 data frame that is not very easy to see by hovering. Before taking a look at the data frame, let's add a couple of columns with the percent calculations to keep our new combined data frame consistent with our other data frames. Open the Explorer and click on your new HTML file to view it. So this data frame that is grouped and combined by subregions has a lot of useful information that is still digestible. Before moving on, let's check the totals to verify that the totals for our subregions are the same as the totals in our main data frame. Looks good. Let's perform the same sorts to our combined group subregion data frame to see what we can learn from it. Open the Explorer and click on your new file to view it. So the fastest growing subregions by population in 2019 were Southern Asia, Eastern Africa, and Western Africa, with a combined population growth of 44 million people. Open the Explorer and click on your new file to view it. The fastest growing subregions by percent increase in 2019 were Middle Africa, Eastern Africa, and Western Africa, all with growth rates exceeding 2%. Open the Explorer and click on your new file to view it. The largest contributors to the total world population by subregion in 2019 were Southern Asia and Eastern Asia. Roughly 47% of the world's population are living in one of those two subregions. Let's take a look at which countries make up the Southern Asia subregion by clicking on the MyDF HTML file. Pretty interesting, right? Before we go, let's save all of our data frames as CSV files. Open the Explorer to confirm that all of your files have been saved. Click in the editor and hit Ctrl+S to save your .jl file. After today's tutorial, you should feel comfortable grabbing data off the internet that is of interest to you. You now have the tools necessary to perform some basic data wrangling activities and some basic descriptive analysis. While the downstream analysis may get more media attention, the reality is that most of the time spent performing analysis happens in this early stage. According to several different sources, up to 80% of a data professional's time is spent finding, cleansing, and organizing data. So while these activities may seem mundane, they are critical skills to possess. The reason why it's important to spend so much time in this early stage is because of the garbage in, garbage out rule. There is no point in performing good analysis on bad data. So it's important to invest the time up front to ensure that you possess good data that is in a format that is ready to be analyzed. The good news is that these skills are scalable, so if you can perform these tasks with a small data set, then you will be able to handle data sets of any size. Well, that's it. Today, after getting a mini tutorial on GitHub, we learned the basics of data wrangling and descriptive analysis. Today's tutorial was less conceptual and more practical, focusing on real-world skills using real-world data. Next week, we'll continue digging into data frames to see how data frames can help us with data visualization. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more Wholesome Julia tutorials, please be sure to subscribe and hit that bell. New tutorials are posted on Sundays/Mondays. If you have any questions, please post them in the comments below. Please feel free to share these videos since these tutorials are getting rave reviews. Just listen to what the professional reviewers are saying.
Extremely impressed.